Question number 3 has a quadrilateral EFGH with 4 vertices that are identified. I'm going to change that up a little bit, and my example is going to have 4 different vertices. I call my quadrilateral ABCD. So what I start doing is I go in and I sketch it. And it looks like it is a parallelogram, but I don't have that as a choice. I have rectangle, rhombus, or square. So it looks like it could be a rhombus. What do we know about a rhombus? We know that the diagonals are perpendicular, and we know that the sides are equal, but we're not going to be talking about the sides. So I've seen a lot of answers turned in that calculate the distance of the sides, and you're just doing twice as much, if not more, work to get the wrong answer and not get credit. We're going to be using diagonals and focusing on diagonals only. That cuts your work in half, because now we only have to find the distance of 2 line segments, not 4. And we're going to find the slope of those diagonals. All right, so I'm going to go on to the next one so I can start showing the work using the distance formula and focusing only on the diagonals. The distance formula, I've labeled these x sub 1, y sub 1, x sub 2, y sub 2, and so forth, because we have 4 different points. And what the distance formula says is whatever point you start with in this first part of your equation, you're going to start with that same point to go and pick up the y value in that coordinate. So I'm going to be looking at this diagonal, AD. So I'm going to be starting with my x value. So I'm just going to remember to go back to this one each time. So it's going to be -2 minus, now go down here to the next point, point D, and subtract the x value in that coordinate, and that's going to be +1. When we simplify that, we're going to square it, and then we're going to add the difference of the y values in each coordinate. So we're going to have to go back to point A, because that's where we started. Because we're subtracting, it will give us an incorrect answer if we switch to a different point each time we start. All right, so the distance of AD, that is my diagonal, one of them. -2 minus 1 is a -3. We're going to square that. It's all underneath a radical. Plus 6 minus 3, that's 3. And we're going to square that. All right, 3 times 3, whether it's positive or negative, anytime you square a number, you're going to get a positive. 2 negatives make a positive. So we have 9 plus 9, or the square root of 18. Now I can simplify that, but I don't have to. I'm just going to compare and see if the other diagonal gives me the same value. And that diagonal is BC. So let's calculate the length of the opposite diagonal. In your problem, if they're equal, it could be a rectangle or a square. If they're not equal, it tells us it's a rhombus. All right, so I'm going to start with 1 point. I'll start up at the top, and I'll subtract the y values. 2 minus -3. And then we're going to square that. Plus, go back to whatever coordinate you started with in your diagonals. And then 7 minus 2. Now I'm going to quickly run through that and see if we have diagonals that are congruent. 2 minus a negative is a positive plus a positive. So that's going to be 3 plus 2 is 5 squared, plus 7 minus 2 is 5 squared. That is 5 times 5 is 25. So that's the square root of 25 plus 25, or the square root of 50. So we can see that those diagonals are not equal. Even if we simplify, we're not going to get equal lengths. So we know right away that it's a rhombus, because rectangles and squares have equal diagonals. But we're not done yet. We need to use the slope formula and go one step further. So let's pull up the next slide. Here's the formula for slope. All right, we're finding the slope of the first diagonal. So we're going to be subtracting our y values in our coordinates. So 6 minus 3 over, go back to the one that you started with, negative 2 minus 1 is 6 minus 3 is 3. Negative 2 minus 1 is a negative 3. That simplifies to a negative 1. Positive 3 divided by negative 3 is a negative 1. So now we want to find the slope of the second diagonal. Again, we're going to start with our y, start with one of the coordinates, start with the y value. I'm starting at the top, going down to the bottom. So I have 7 minus 2 over, go back up here and get your x values, 2 minus negative 3. Be careful with your negatives. 2 negatives make a positive. 7 minus 2 is 5, and 2 plus 3 is 5, and that simplifies to a positive 1. Now you have proven that your diagonals are perpendicular, because slopes of perpendicular lines are negative inverses of each other. A simple test is to multiply your slopes together, and if your result is a negative 1, negative 1 times positive 1 is a negative 1, that proves that your lines are perpendicular. All right, so that's the last one. It gives you all the points for showing your work and getting the correct answer.